Hello everyone. This is a review presentation that you can use to study for the upcoming quiz and even the unit test that will follow a few days later. Today we'll be reviewing states of matter, which will cover learning targets 1.1, 1.2, and 1.3. What we have learned in our states of matter is that solids, we can't quite see it, have a definite volume, solids have a definite shape, and they're in a fixed lock position tightly packed. You can see with these particles that there's not very much space in between each one, very tightly packed. In addition, solids vibrate in place and have a low energy level, and a few examples are rock, paper, and scissors. The biggest thing to remember is this vibrate in place and that they are tightly packed, similar to what you see in this picture. The next state of matter is liquids. In liquids, they roll or slide over each other. This is their motion, which is very important. You have to be able to describe the motion. So you're going to look at these words here, roll and slide, very important. For their energy, they have a medium amount of energy, which is why they can roll and slide, but they don't fly around. They have enough energy to roll and slide, but not enough to fly around. Examples: water, juice, tea. These are all examples of liquids. I like to think of liquids, or the motion of liquids, like ballroom dancing, rolling, sliding past each other, pretty tightly packed, but not super tightly packed. So if you see here, we have this motion here, where we're going to have atoms moving around each other, and you can also see there's a little bit of space here, a little bit of space here. Tiny bit more space than what we would have with a solid, but not as much space in between the particles as a gas. The volume is definite in a liquid, which means we cannot push these particles into any smaller space. There is no definite shape, which means they can fill any container, they can be any shape. I mean, it's pretty obvious. A liquid can change shapes. And not fixed, not locked, loosely packed. Very important. Once again, we're talking about liquid state of matter. Let's talk about gases. As you can see here, the particles are spread out. No definite volume. That's because there's so much room that we can actually take all of these and compact them into a much smaller space if we wanted to. We could fit them all in there. Not a definite volume. So that is definitely an important point to remember about gases. Also, they have no definite shape because of the proximity, and they're not really near each other. They're flying around, bouncing off of each other. In a gas, the motion is to bounce and collide, and it's because they have a high energy level. So the important part here is bounce and collide, because remember, you have a learning target that says you have to describe the motion of the particles. The energy level is high, and that's why they bounce, and that's why they collide. They have a lot of energy. So really what they're trying to do is get away from each other, but ultimately, because they're moving so fast, they end up running into each other. And that's where the bouncing and colliding comes from. Next, we're going to skip plasma, and we're going to talk about changing state. Changing state is very simple. When matter changes between a solid, liquid, and a gas, it's all because of energy. The question is, does energy go up or does energy go down? And that will decide what change in state occurs. Let's take a look at this diagram. If energy goes up, you notice there's an arrow here. Energy goes up, that's increases. Okay, increase. If that happens, then a solid is going to turn into a liquid, more motion. And then a liquid will turn into a gas, more motion. Now, if energy were to decrease in this direction, then a gas would turn to a liquid, less motion, and a liquid would turn to a solid, less motion. This is how we change from one state to another. It's all about this key word in the middle, energy. If there's enough energy given, then the state of matter will change. And if there's enough energy taken, the state of matter will also change. It depends on whether there is an increase or decrease. An increase always leads to more motion, and a decrease always leads to less motion. And that is where we will conclude our review for states of matter. If you need any help, please see your instructor. Good luck.